Welcome to the Deep Dive, where we cut through the noise, sift through your sources, and deliver the insights you need to be truly well-informed, fast. Today, we're tackling a challenge that's really top of mind for countless startups and lean teams. How do you build out serious machine learning capabilities? Predictive maintenance, personalized recommendations, without spending like a tech giant? We're diving into the ultimate guide for crafting a cost-effective, open-source MLOps stack in 2025. This deep dive is, well, it's tailor-made for technical founders, ML engineers, and DevOps pros at early-stage startups, especially those of you maybe navigating this space without a dedicated MLOps team.
Yeah, and what's truly insightful about open source for startups, I think, isn't just the zero licensing cost, though that helps. It's really how it fosters this lean, adaptable mindset. You're almost forced to understand the foundations of your MLOps stack,
Right.
which, often leads to more robust, custom-fit solutions rather than just grabbing some off-the-shelf thing that might be bloated. It's really an investment in understanding your own infrastructure, not just consuming a service.
That's a great point. So our mission today is basically to walk you through a tool-by-tool blueprint, looking at the open source stack that's making waves right now in 2025. We'll cover budget-friendly options, the trade-offs, those are critical, and some integration tips. But before we get into the specific tools, let's just nail down a fundamental concept. What is MLOps, really?
Right. MLOps, machine learning operations, it's basically the bridge between data science and engineering. All the practices, the tools, the workflows, everything you need to deploy and monitor and manage machine learning models effectively in production.
Okay.
So you're training a model in Notebook, that's one thing. Getting it to deliver continuous, reliable value to users day in, day out. That's where MLOps comes in.
Got it. Moving from experiment to actual business asset.
Exactly.
All right, so let's trace this MLOps journey. The source mentions a life cycle with several core stages. What are these stages, and why is each one, non-negotiable for a startup that needs reliable, repeatable ML?
Yeah, the source lays it out pretty clearly in sequence. It starts with data ingestion and versioning. Then you've got experiment tracking, workflow orchestration, model deployment or serving monitoring, and finally wrapping it all up is CI/CD specifically for ML.
Okay.
And the key idea for startups, according to the source, isn't building some huge over-engineered platform. It's more about embracing what they call minimum viable MLOps or MVMLOps. Keep it lean, modular, ready to scale.
Minimum viable MLOps. I like that. So stage one, data ingestion and versioning. The goal here is collecting, cleaning, managing data, making sure it's reproducible, right? Without needing tons of expensive infrastructure.
Precisely. Data is arguably as important as code, maybe more so. But versioning it is tricky. You've got huge files, constantly changing data sets.
So what tool cuts through that complexity for open source users?
Well, for data versioning, the name that comes up again and again is DVC, data version control. It's pretty much become the open source standard here. It brings Git-like workflows, things you already know, to your data and ML models.
Git-like workflows, how does that work?
Imagine being able to track changes to your data sets, manage large model files, share experiments, all using commands similar to Git, right, within your existing Git repository.
Right.
Plus, it integrates really smoothly with remote storage like AWS S3 or Google Cloud Storage.
Okay.
And it plays nicely with CI/CD systems, too. It's genuinely a game changer for reproducibility, especially for lean teams.
VC sounds powerful, but, for a startup with limited bandwidth, is setting it up a big hurdle? Or is it reasonably lightweight?
That's a fair question. It's actually designed to be pretty lightweight. It integrates with tools you're likely already using, like Git and cloud storage. So the setup overhead is, well, surprisingly low compared to the massive reproducibility headaches it solves.
Okay. Are there simpler alternatives if DVC feels like too much initially?
Yeah, for really simple cases, there's Git LFS large file storage. If you're just dealing with a handful of big binary files and you're already deep into GitHub, it's an option.
Yeah.
But it really lacks the ML-specific features of DVC, and the free storage on platforms like GitHub is quite limited. There's also an emerging, maybe more powerful option called LakeFS. It brings Git-like versioning directly to object stores like S3, think atomic commits, branching, rollbacks, but for potentially terabyte-scale data lakes.
Wow.
Probably overkill for modest needs, but something to keep an eye on if you're dealing with massive data.
Okay, so data is versioned.
Yep.
Now, the next headache, tracking all those experiments, right? Models, parameters, metrics, artifacts. It can get chaotic fast. What's the go-to open source platform here?
For experiment tracking, yeah, MLflow is a really strong contender in the open source world. It gives you a straightforward but still powerful interface for logging experiments, visualizing metrics side by side, managing model artifacts, packaging models, the whole life cycle,
Like
basically.
self-hostable?
Yes, completely self-hostable, which startups often like. No vendor lock-in. It integrates really well with Python scripts, popular ML frameworks like TensorFlow, PyTorch, Scikit-learn, and it scales pretty well.
Okay, self-hosting gives control. But are there alternatives, maybe with free tiers, that offer a more polished, collaborative feel out of the box?
Absolutely. Two big ones come to mind with generous free tiers. First is Weights and Biases, or WB. It offers this really polished, cloud-based experience, great visual dashboards, real-time updates, very strong on collaboration feature.
Plug and play feel?
Yeah, pretty much. Great for distributed teams. Then there's Neptune.ai. Neptune takes a slightly different approach, positioning itself as more of a metadata store plus experiment tracker. It offers very fine-grained control over what you log, also very focused on collaboration, and again, has a good free tier to get started.
So the choice there is sort of control versus convenience.
Kind of, yeah. It's about balancing that desire for complete self-hosted control with ML flow against the immediate collaborative benefits and, frankly, the time savings you might get from WMB or Neptune's free tiers. Depends on your team's comfort with infrastructure and collaboration style.
Makes sense. Okay, experiments tracked, models improving. Next step, workflow orchestration. This is about automating those multi-step ML pipelines, data prep, training, evaluation, deployment.
Right, and for this crucial stage, Prefect has become a real favorite recently. Its big appeal is its Python native, very modern approach. You basically build your workflows using regular Python functions and decorators.
Just Python functions, not complex config files.
Largely, yeah.
Yeah.
Which developers tend to love. It also has a really nice UI for visualizing pipelines, debugging failures. It supports async tasks, automatic retries, scheduling, all the stuff you need. And you can self-host it or use their Prefect cloud service.
Okay, that sounds appealing for fast iteration. So if a startup wants speed and minimal infrastructure wrangling, Prefect seems like the sweet spot. What's the biggest difference a developer would actually feel day to day choosing Prefect over, say, the big incumbent, Airflow?
I think the biggest feeling is just simplicity in developer experience. With Prefect, you're writing Python. It feels natural if you're already working in Python for your ML. You're not context switching as much, wrestling with complex DAG definitions in a separate structure like you often do with Airflow.
Less friction.
Exactly. Less friction. Hours saved debugging configuration rather than model code. Now, don't get me wrong, Apache Airflow is the industry standard for a reason. It's incredibly robust, especially for complex scheduling and traditional ETL, but it generally has a steeper learning curve and, yeah, more maintenance overhead, which can be tough for lean teams.
And Kubeflow pipelines.
Kubeflow pipelines is powerful, purpose-built for ML and Kubernetes, highly extensible, but it really requires significant DevOps maturity and deep Kubernetes expertise. Probably not the starting point for most early-stage startups.
Okay, Prefect for the Python native win, potentially. So models trained, pipelines orchestrated. Now we need to get them out there. Model deployment or serving. Packaging models as APIs, making them fast, reliable, scalable in production. What's the open source play here?
A really popular choice, especially for developer-focused teams, is Bentham ML. It aims to simplify that whole process. Packaging models from various frameworks, TensorFlow, PyTorch, Scikit-learn, XGBoost, you name it, and deploying them as REST or gRPC APIs.
How simple is simple?
We're talking potentially just a few lines of Python to define your service, package your model, and build a Docker container. It has built-in containerization support, makes cloud-native deployment much easier. It's really designed for teams that want to serve models without becoming infrastructure experts overnight.
Right. But what if a startup scales up fast and needs more sophisticated deployment strategies, like A/B testing models or canary releases?
Yeah, for those more complex large-scale scenarios, Selden Core is the more powerful option. It's Kubernetes native, designed for advanced stuff. Complex inference graphs, explainers, outlier detectors, sophisticated routing like A/B tests, canary deployments, multi-armed bandits.
Okay, sounds heavy duty.
It is. And with that power comes complexity. Selden Core definitely has a steeper learning curve and absolutely requires solid Kubernetes knowledge on the team.
So again, a trade-off. Bentham ML for simplicity and speed to deploy, Selden Core for advanced features but higher overhead.
Precisely. The choice really hinges on your team's current DevOps capabilities and how complex your deployment needs are right now versus maybe in the future. Starting simple with Bentham ML is often wise.
Got it. So model deployed. Job done, right? Or is that where the real fun begins?
Yeah, that's a common misconception. Deploying is just the start. Models can and do degrade in the real world, sometimes silently.
Silently, that sounds bad.
It is. That's why model monitoring is absolutely mission critical. You need to catch issues before they impact users or waste compute resources.
So what are we monitoring for specifically, and what's the tool?
You're looking for things like data drift. Is the input data changing from what the model was trained on? And concept drift, has the underlying relationship between inputs and outputs shifted? Also things like target leakage, weird feature distributions, missing values popping up. For this, evidently AI is a really strong open source choice. It's purpose-built for monitoring ML models, specifically for these kinds of drift and data quality issues.
Purpose-built, okay.
Yeah, it offers out-of-the-box reports and dashboards for drift detection. It's relatively lightweight and easy to integrate into pipelines.
So it helps understand why performance might be dropping, not just if.
Exactly, it gives you diagnostics. Now, if your team already has robust DevOps monitoring set up,
like Prometheus and Grafana.
right, you can adapt Prometheus plus Grafana. You can track ML-specific signals like inference latency, error rates, resource usage, but it requires more custom configuration. You have to define what metrics matter, set up the collectors, build the dashboards yourself. It doesn't give you those ML-specific diagnostics like drift detection out of the box.
So more work involved.
Definitely. Regardless of the tool, you need to track key things: data drift, concept drift, latency, prediction confidence or uncertainty, error rate accuracy degradation, and any anomalies in your input features like unexpected nulls.
Okay, critical stuff. And the final piece tying this all together for scalability and reliability. CI/CD automation for ML, automating retraining, validation, deployment as data changes. Bringing that software engineering discipline to model.
Exactly. And the tool that stands out here, especially since we mentioned DVC earlier, is CML, Continuous Machine Learning. It's actually by the DVC team. It's designed specifically to bring ML workflows into existing CI/CD systems like GitHub Actions or GitLab CI.
How does it do that?
It lets you run model training scripts, evaluation steps, and crucially, generate reports directly within your CI pipeline. Imagine getting a comment on your pull request showing how the model performance changed, automatically generated. That's what CML enables.
That's pretty cool. Can you just use standard CI/CD tools without CML?
You can, yes. If you're already using, say, GitHub Actions, you can definitely extend it to handle simpler ML workflows. Maybe trigger retraining on a schedule, run some basic validation tests, push model artifacts to storage.
But CML adds more ML-specific smarts.
Right. It streamlines those common ML tasks within the CI/CD context. The bigger picture here, though, is that the line between DevOps and MLOps is getting really blurry. Adopting CI/CD for ML using tools like CML or even just well-configured GitHub Actions is what empowers startups to iterate faster. It ensures models stay fresh and reliable because new data can trigger retraining automatically, and validation checks prevent bad models from getting deployed. Automation is key.
Okay, wow. We've covered a lot of ground, tool by tool, DVC, MLflow, Prefect, BentML, evidently CML, quite the stack.
Yeah.
But here's the million-dollar question. How do you actually stitch all these amazing open source pieces together into one cohesive, automated system?
Ah, yes. The integration challenge. That's where the real MLOps magic happens, or where things can fall apart. The essential glue, really, for modern MLOps integration, especially in the open source world, boils down to three core technologies: Docker, Kubernetes, and Helm.
Okay, break those down. Docker.
Docker is about containerization. It ensures every component, your data processing script, your training code, your model server, runs in a consistent, isolated, reproducible environment. No more, well, it worked on my machine.
Kubernetes?
Kubernetes, often abbreviated K8s, is the orchestrator for those Docker containers. It handles deploying them across a cluster of machines, scaling them up or down automatically based on load, managing resources efficiently, and handling failures gracefully. It's the platform for running containerized applications reliably at scale.
And Helm?
Helm sits on top of Kubernetes.
Yeah.
It's like a package manager. It simplifies deploying complex applications, like maybe your entire ML pipeline with all its services, onto Kubernetes. You define everything in templates called charts, making deployment and upgrades much more manageable.
So Docker packages things up, Kubernetes runs and scales them, Helm deploys them easily.
That's a great summary, yeah. Together, they let you package your entire ML pipeline, from data ingestion using maybe DVC to training orchestrated by Prefect, logged by MLflow, served by BentMLM, to these portable, manageable, scalable units.
What about the collaborative environment, like where data scientists actually work?
Right. For that, Jupyter Hub is excellent in an open source context. It allows multiple users to have their own isolated Jupyter notebook environments, but running centrally, maybe on Kubernetes, with shared resources and proper authentication. So to make a workflow truly reproducible end-to-end, you'd combine DVC for data and model versioning, MLflow for tracking the experiment parameters and results, Prefect orchestrating the steps, and Docker files defining the exact software environment for each step.
Can you walk through a quick example of how that flow might look?
Sure. Imagine a typical training pipeline run orchestrated by Prefect. Step 1. Prefect triggers a job that uses DVC commands to pull the correct version dataset from S3. Step 2. Another job runs the training script using MLflow to log parameters like learning rate and metrics like accuracy, maybe saving the trained model file.
Okay.
Step 3. An evaluation job runs compare the new model's metrics, log in MLflow, against the currently deployed model. Step 4. If the new model is better, Prefect registers it, maybe tags it in MLflow, and triggers another job using BentML to build a new Docker image for serving. Step 5. That image gets deployed, maybe using Helm to update the Kubernetes deployment. And Step 6. Maybe it sends a notification to Slack saying new model deployed and ensures evidently AI is pointed at the new endpoint for monitoring.
Wow, okay, that really connects the dots. Seeing how Prefect orchestrates calls to DVC, MLflow, BentML, that makes sense. But speaking of complex systems, security is always a concern. Just because these tools are open source, that doesn't mean they're inherently secure, right? Are there common pitfalls startups overlook?
Absolutely critical point. Open source does not mean insecure, but it also doesn't mean automatically secure. You own the security posture. Startups, especially when moving fast, can definitely overlook key vulnerabilities.
Like what?
Well, things like not managing secrets properly, API keys, database passwords just checked into Git. You really need secrets management tools like HashiCorp Vault, even the secrets management in Kubernetes itself. Also, not setting up proper role-based access control, RBAC in Kubernetes, giving containers too many permissions. Not regularly scanning Docker images for known vulnerabilities using tools like Trivy or Snike. And not using network policies in Kubernetes to restrict which services can talk to each other. Basic network segmentation.
So security requires active effort. It's not just built in.
Exactly. It's an ongoing process, regardless of whether your tools are open source or commercial. You have to be proactive.
All right, this next point feels like a potential blind spot for many, especially when attracted by free software. We've been talking about cost-effective open source tools, but the source material strongly suggests the actual cost of ownership can really sneak up on you. How does that happen? Where are the hidden costs?
Yeah, this is super important. Free open source software is free like a puppy is free, right? The initial cost is zero, but the upkeep.
Huh. Good analogy.
The real cost of self-hosting involves significant hidden expenses. First, plain old infrastructure costs. Hosting DDC remotes on S3 costs money. Running MLflow servers, Prefect agents, maybe an Airflow scheduler, definitely a Kubernetes cluster that all consumes cloud compute and storage, and those bills add up.
Right, the cloud provider bill.
Then there's the operational overhead. This is often the biggest hidden cost. You need people, DevOps engineers, MLOps engineers, or just your existing developers spending their time to set up, manage, update, patch, troubleshoot, and scale all these different tools. That's significant engineering time.
Time that could be spent building the actual product.
Exactly. And finally, there's the learning curve. Your team has to master these tools, their configurations, how they integrate. Open source documentation can be variable, and support often means searching forums or GitHub issues yourself. More time spent troubleshooting.
So the source actually quantifies this.
Yeah, it makes a pretty bold claim. The
Right.
total cost of ownership for self-hosting often exceeds the cost of using comparable managed cloud services by potentially 30–50% once you factor in that engineering time.
Wow, 30–50% more expensive potentially. That's huge for a startup.
It really is. It forces a serious calculation about where your team's time is best spent.
Okay, so it's not just about the software license cost, it's the people hours and the underlying cloud spend. Given that, what is the sweet spot for a startup? How do you balance performance, cost, and this complexity factor?
That's the core dilemma, isn't it? Open source gives you ultimate flexibility, modularity, no vendor lock-in.
Yeah.
But it comes at the cost of that added complexity and management burden. Managed services, on the other hand, often trade some of that flexibility for speed, ease of use, and reduced operational load.
So what's the recommendation? Go all in self-hosted, all in managed.
The recommendation for startups generally is to start lean and be strategic. Begin with a minimal self-hosted stack for the core differentiating parts. Maybe focus on self-hosting DVC, MLflow, and Prefect initially, as they provide a lot of value relatively contained.
Start small, prove the value.
Right. and only scale up to more complex orchestrators like maybe Airflow or Kubeflow or more intricate integrations as you actually need them. Don't over-engineer from day one. And critically, consider using managed services for the non-differentiating parts of the stack. Maybe use a managed Jupyter Notebook service instead of setting up Jupyter Hub yourself. Or perhaps use a simple serverless function like AWS Lambda or Google Cloud Functions for basic model serving initially, instead of managing Ventimel or Seldon on Kubernetes right away.
So a hybrid approach.
Exactly. Be pragmatic. Where does self-hosting give you a real advantage or control you need? Where does a managed service save you time and operational headache that's better spent elsewhere?
Which implies there are definitely scenarios where paying for a managed service might actually be cheaper overall for a startup.
Absolutely. Sometimes going with a fully managed platform like AWS SageMaker, Google Vertex AI, or Azure Machine Learning is not only faster to get running, but genuinely cheaper in the long run. Especially if your team is small, lacks deep MLOps expertise, or you have strict compliance requirements or service-level agreements, SLAs, to meet quickly.
Because they handle the infrastructure, the scaling, the security.
Precisely. They offer integrated pipelines, auto-scaling infrastructure, enterprise-grade security, often with 247 support baked in. That operational burden is shifted to the cloud provider. In fact, the source notes that the dominant trend among successful high-growth startups isn't pure open source or pure managed service. It's increasingly this hybrid MLOps adoption.
Mixing and matching.
Skillfully mixing the best open source tools where they make sense with cloud-managed components where they make sense.
That's a really practical perspective. Okay, shifting gears slightly. Beyond just building great products, there's a point made about how mastering these MLOs tools can be a huge career boost, even a revenue opportunity. For you, the listener, whether you're an individual engineer or part of a startup team, what does really getting good at this stuff unlock?
Yeah, this is important. Mastering key tools in this open source MLOps ecosystem, DVC, MLflow, Prefect, BenML, Kubernetes, it doesn't just let you build better, more reliable ML systems. It directly positions you for more senior roles, highly sought after freelance or consulting contracts, maybe even building your own productized services around this stack.
Any recommendations for structured learning?
The source specifically mentioned Udacity's machine learning engineer nano degree as a solid option. It apparently includes hands-on projects covering model deployment, CI/CD pipelines, monitoring implementation, the practical skills companies are looking for. And beyond just the core MLOps tools we discussed, to really thrive, professionals should probably also get comfortable with Docker for containerization fundamentals, Kubernetes for scaling, maybe Terraform for automating the cloud infrastructure itself.
Infrastructure as code, right.
Exactly. And probably a major deep learning framework like PyTorch or TensorFlow, and something like FastAPI for building performant Python APIs to actually serve the models if you're not using a dedicated tool like BenML.
That's a solid skill stack. Now, you mentioned revenue opportunities beyond a standard job. How can someone actually monetize this MLOps expertise?
That's where it gets really interesting, especially for entrepreneurial folks. Mastery opens several doors. Obvious one, freelancing or consulting. Lots of early-stage startups desperately need MLOps help, but can't afford a full-time hire. You could specialize in setting up these open source stacks for them.
Be the MLOps expert on demand.
Right. Then there's content creation. If you enjoy teaching, you could launch a blog, a YouTube channel, maybe a paid Substack newsletter focusing on practical MLOps, tutorials, tool comparisons, case studies. Build an audience.
Share the knowledge.
You could create digital products, things like pre-built project templates, CI/CD starter kits using CML or GitHub Actions, well-structured Helm charts for deploying common MLOps tools. Sell things that save other people time.
Okay, assets.
And related to content, online courses. Maybe not a huge nano degree, but focused mini courses on specific niche tools people struggle with, like getting DVC set up correctly, or building complex prefect flows, or optimizing BenML deployments.
Niche down.
Exactly. The point is, with the right knowledge and positioning, even a solo developer can build significant income streams around the demand for practical MLOps infrastructure skills.
That's really empowering. So, wrapping things up, as people listening look to build or scale their own ML capabilities, what's the core takeaway from our deep dive today? It feels like the message is, building a serious high-performance MLOps stack doesn't have to mean breaking the bank.
Definitely not. That's the key message. With the right combination of these powerful open source tools, some thoughtful orchestration connecting them together smartly, and leveraging cloud-native practices like containers and Kubernetes. Startups can absolutely build sophisticated ML capabilities and compete effectively even against much larger players without burning through all their capital on expensive enterprise licenses or managed platforms if they choose carefully.
We've walked through a pretty practical, cost-effective blueprint, really, covering the whole life cycle with proven, scalable, reproducible tools.
Yeah, a blueprint for designing and operating that ML lifecycle, focusing on technologies that are production ready but accessible.
And remember, this deep dive, it's just the foundation, right? The journey doesn't end here. The source materials have links to related articles with more hands-on tutorials, detailed tool comparisons, best practices for integration. Definitely worth exploring those.
Yeah, there's even mention of a GitHub starter repo with boilerplate code to help you get up and running faster with some of these tools integrated.
Oh, that's handy.
And don't forget the communities. Places like the MLOps community on Slack are super active, great places to ask questions, share experiences, learn from others navigating the same challenges.
Right, it's not a solo journey. So, the final thought seems to be, MLOps isn't a checkbox you tick once. It's an ongoing process, a journey of continuous improvement, always aiming to make your ML systems faster, cheaper, more reliable, smarter.
Exactly. Iteration is key.
But with the blueprint we've unpacked today, hopefully you feel better equipped to start that journey or refine it, building smarter, faster, and perhaps more collaboratively.